So I'll start with the sketch. And what we'll do first, we're going to look at the function as a graph. Later on, we'll talk about the real-life application of these sort of things. So I'm going to take a random function in xy, like so. And the graph of this function has the following characteristics. Okay. And this function has both endpoints, like so. Okay? So this is a generic function y equal f of x. And let's see what point on this graph has some interest to us. Okay? This graph does not necessarily go through the origin, by the way. So as I go from left to right, I say, you know what? I'm interested in this point right there, the beginning of the point. So let's say the graph goes from A to B. Okay, so I'll call this point x1, and it's A. What is the next point I'm interested in? Well, I'm interested in this point, which I'll call x2. I'm interested in this point, x3. Now, why I'm interested in this point? Because if you look at the title or the topic, it says maximum and minimum. And that's why I'm investigating these particular points. So this will be x4, and x5 will be the last one, which I call B. Okay, so we're looking at these three interior points plus the two endpoints. And what we're interested to know is at what point this graph has a maximum and at what point this graph has a minimum. Okay? So let's use a little bit of vocabulary here. And we're going to say, in terms of vocabulary, since maximum, minimum, or an extremum are all Latin words, then they have single form and plural form. Singular form, we are looking at maximum or maxima. If you have plural, you have minimum or minima. Media. Is media a plural form or singular form? Media.
Media?
Yeah, like what do we refer to media? In journalism. Is it minimum? Is it masculine? Is it singular or plural form? It's plural. The singular form for media is medium. Okay? So, but we tend to refer to media as a singular form. But really in Latin, now both maximum and minimum can be called extremum. If we don't want to use the term maximum or minimum, we can refer to extremum, which encompass or include both terms, and of course the plural form will be extrema. So those terms will you'll hear a lot in terms of vocabulary. So let's see what we have. We have certain points where in the vicinity we have a local, what we call local extrema. For instance, near x equal 2, all the points near x equal 2 are greater than x equal 2. And what's unique to x equal 2 is that the derivative, or the slope of the derivative, is 0. The tangent is horizontal. Likewise, x3 represents a local maximum because every point near x3 is less than x3, or has a y value that is less than f of x3. x4 represents what we call a local minimum. For the same reason, near x4, all the y value will be greater than f of x4. Okay, so we're going to say that we have a local minimum at x2 and at x4. On the other hand, we're going to say that we have a local maximum at x3. Where is the absolute maximum of all the points on this particular closed interval graph? Where is the highest y value? It will be the y value that corresponds to x5, which will be this point. And this point indeed will be the global, what you call global or absolute maximum. What about this point right there at x1? Does it play any role? Is this a local maximum or global maximum or global minimum or local minimum? Well, it's not. It's neither. It's not a minimum to begin with because the point in the vicinity of x1 are less than f of x1. So all the y value that coming immediately after that are smaller. So it cannot be minimum, but do we consider this as a local maximum? The answer is not in this course, not when it comes to calculus 1. We consider a local maximum only points that are not part of the, that are not the endpoints, that you can move either to the right or to the left. Okay? Endpoints can be either global maximum, minimum, or nothing. If you take applied calculus, then the definition will include the endpoints. So if this was an applied calculus, then this would have been a local, x1 would have been a local maximum, but not in the theoretical calculus, as is this course. Okay? So we heard some other terms in addition to maximum, minimum, extremum. We're going to use the term global and local. Okay? And the word local is synonym with relative. So instead of local maximum or local minimum, I could have used local, a relative, and the word global, which I used as well, can be is synonym with absolute. So we go either local global or we go relative absolute when it comes to maximum minimum. And time for me to give you the definition. So let's write some definitions. Let's start with absolute or global extremum or extrema. Here we have a definition for maximum and a definition for minimum. The first definition will be, we're going to say that f of x has a maximum, a global or absolute maximum, so I'll meet at a maximum at x equals c if f of c is greater than or equal to f of x for all x in D. D is the domain of f of x. Okay. Likewise, we're going to say that, actually I'm saying it right now, where D is the domain of f of x. Likewise, we're going to define a minimum, a global or absolute minimum, in a similar manner. We're going to say that f of x, by the way, there is an extra if here. So I think I read it correctly, but I used if. I wrote if unnecessarily. So the first statement, f of x has a maximum at x equals c if f of c is greater than or equal to f of x for all x in D. So that will be f of x is the highest value of y. And for minimum, it will be the same, f of x as a minimum at x equal c if f of c is less than or equal to f of x for all x in D. So those are the definition for global or absolute. Let me give you the definition of the relative or local. And you can look at the difference between the two. Okay. So for maximum, we're going to say that f of x has a relative maximum at x equals c if f of c is greater than or equal to f of x for values of x in an open interval near x equals c. Okay. Notice that in an open interval, it excludes any point, because the endpoint will make the interval close. The other thing I want to attract your attention, when we include the word relative, when we exclude words like relative, we mean absolute. Notice that here, in the first two paragraphs, I said maximum or minimum. I did not specify global or absolute. This is the default definition. So if we say a function is a maximum, we mean global or absolute. If we mean relative or local, we're going to say so. So omission of relative or local mean global. Okay? Let me quickly write the last one and we'll call it a day. f of x has a relative or local minimum at x equals c if f of c is less than or equal f of x for values of x in an open interval once again near x equals c. And as before, I'm going to underline the open interval as well. All right, examples will be given after the test because I'm out of time. Well, I have a minute, but it's not enough time to give you an example. So I'm going to stop here. I'll see you on Tuesday for a Q&A session for the test, and then on Wednesday, other test.